In the this is transferation and stomatoconductance, that sheet. And in the beginning, we only have T leaf, and Martha asked us to correct GSW by T leaf. But after that, she sent us a new email that we should correct by T reference, which is the temperature of the machine something. But we found that there's no really strong correlation between GSW and T reference. As here, we do like a linear regression plot for GSW and T ref, and we can see that there's no any pattern, and the R square is very low. And at the same time, we also do with the E apparent, and also there's no obvious pattern. So we just don't do any correction for GSW and E apparent. This is the first thing. And then we do some PCA. And Martha asked us to separate like GSW. There's a different date for GSW, and everything is the same for GSW to QM AMB. And she asked us to separate GSW by different dates and do a huge PCA. So we have so it's like this. There are so many different dates in the raw data. There's even a August 22 in it, but after I observed the data, and I found that maybe August 22 is a extra one, so we have to ignore it. So I just transfer these date into a number, because like for each date they should have the same number of observation, but I found that it's different. Like in the original date and TSCon is the original sheet, and we can see that every date should be 20 observation, but it's obvious that these two dates is together because the sum is 20. So the same things, and you can obviously see that this is extra one. So I just change, like these two dates become 2, so I change it. I change it. So it becomes like this is 5 different section. Just consider it as different dates. So this is what I show here. And for the PCA, we separate different dates, different tester, different leaf water potential. They're also just separate dates. Just put everything together into one PCA. And I know that it's not so easy to see. And I think Yumi has a report to state what is the group. Like in this group, what are those variables? I think there's a report. We can put this later. So in this PCA, there's not only things from transparent data, there's also from the general data. So this is everything here. So you can just look at it. And for the test result, I put a CSV here. And the first column is different variable. And here's the note of like if this variable, the data doesn't follow normal distribution or it's not equal variance to the soil management for different modality. So there's a note, EV is equal variance. And if soil management and training system, they have some interaction, here will be like this. and the result is all the test result. If it doesn't follow normal distribution, then we cannot do ANOVA. So we have to do Kruskal-Wallis test. So these are the p-value, and also here we'll show the results. Like if like this training system is very small p-value, so there will be here. And if it doesn't has the equal variance, we can do Welch one-way ANOVA. So but Welch cannot do two ways ANOVA, so I have to separate, just like Kruskal-Wallis test, like this. So also the result is here. And if there's no problem, like the normal distribution is okay and equal variance is also okay, then we can do ANOVA. And this is the two-way ANOVA. So they will give the result of training, soil, and interaction. And here is the p-value, and also all the result will be recorded here. And if the training system is significantly having effect, then I will do Tukey HSD for training system. So these three columns are the result of Tukey HSD. So we can see that which pair of training system is significantly different. And also here is some memo, so you can see that whenever you want. And I think it's not so easy to see from here because here something is blocked. So you can just download it, then you can do whatever you want to do. And also because I found that I check equal variance by Loving test, but I found that there's so many variables that doesn't have equal variance. So I was thinking maybe Loving test is so too sensitive. So I also do a plot. I only do the plot for those variables that are fail on Loving test. So these are those variables, and theoretically, if they have equal variance, the range, like here's 5 lines, right? Each line refers to one modality. And these 5 lines, the range should be similar, so they are equal variant. But they're indeed not so similar, because they already fail on Loving test, so it's reasonable that they're not so similar. But reading the plot is so subjective, so I just do the plot, but we can either just follow Loving test, or we can still have some explain according to the plot. So when you analyze, you can choose either on Loving test or E-apparent. If you prefer to follow the plot, you can tell me which plot you think that it's actually still we can consider it as equal variance, and I can do those variable for the ANOVA. Or we can just this table is following Loving test, because I really don't know how to explain those plots. They just looks different.